Hey guys, so this module is about prime factorization. I didn't think much about the video, it's going to be on the fly, but here we go. Prime factorization is when we want to write all the prime factors of a number. So we want to get until the end, when can we no longer split up a number? So let's start with 60. I want to think of two numbers that multiply to give me 60. Usually we like to start with the smallest numbers. So I'm going to start with 2. 2 times what gives me 60? If we put that in a calculator, 60 divided by 2, that gives us 30. 2 I can't split up anymore, but 30 I can keep going. So I want two numbers now that multiply to give me 30. I could try 2 again. So 2 and 15. 2 I can't split up anymore, but 15 I can. 15 cannot be divided by 2, but we can try 3. 15 divided by 3 is 5. And so now we have the prime factorization. What this means is that the numbers 2 times 2 times 3 times 5 will give us 60. You can see that they're the end of the branches of this tree that we've made. Let's try 369. So I'm going to write some of the primes we want to start thinking about. So 369 cannot be divided by 2. So let's try 3. 369 divided by 3. That gives us 123. Okay, let's keep going. 123 we can split up, and I'm just going to move the order in which I wrote these. 3 we cannot factor anymore, but 123 we might be able to. So let's see, let's try 123 divided by 3. That gives us 41. Now 41, no matter what we try, we're not going to be able to find numbers that split up to multiply it. That's because it is what we call a prime number. So this is where we stop. Here are all the primes that multiply to give us 369. Now this number is a negative. Whenever you have a negative, I want you to start by writing it as -1 times the number. So -90 we can write as -1 times 90. Now we can start with the prime factorization of 90. We can do 90 divided by 2. That'll give us 45. Now 45 we cannot divide by 2. But let's try 3. 15. 3 can't be split up anymore, but 15 can. So we have, we could try 3. 3 times what gives us 15? That's 5. And now we have our complete prime factorization. So we know that -1 times 2 times 3 times 3 times 5 gives us -90. In this example, we want to expand this expression. 32, a to the 6th, b to the 2nd, c to the 3rd. Because we've just done exponents, you guys know how to expand this. That's a times a times a times a times a times a times b times b times c times c times c. But in order to expand 32, we need to do a factor tree. 32 can be written as 2 times 16. 16 we could write as 2 times 8. 8 can be 2 times 4. And 4 can be 2 times 2. So that's 1, 2 times 2 times 2 times 2 times 2. 5 2's. And now this is the expansion of our expression. In this example, I want us to simplify a fraction, but I want us to use a factor tree in order to do that. So we have 14 over 49. What does that simplify to? Well, let's make two factor trees. 14 we could split into 2 times 7. 7 doesn't have any more factors, so we're done. These are the prime factors. 49, we could split into, it won't divide by 2, won't divide by 3, won't divide by 5, but it divides by 7. 7 times 7. And then those are the prime factors of 49. So if we rewrite this fraction, 14 49ths, we get 2 times 7 divided by 7 times 7. As you know from exponents, we can divide those sevenths, and we're left with 2 over 7. There's our simplified fraction.